Possible scenarios. Singleton design pattern. Singleton pattern restricts the instantiation of a class and ensures that only one instance of the class exists in the Java virtual machine. The Singleton class must provide a global access point to get the instance of the class. Singleton pattern is used for logging, drivers objects, caching and thread pool. Singleton design pattern is also used in other design patterns like abstract factory, builder, prototype, facade, etc. Singleton design pattern is used in core Java classes also, for example Java, Lang, Runtime, Java, at Desktop. Java Singleton pattern implementation. To implement a singleton pattern, we have different approaches but all of them have the following common concepts. Private constructor to restrict instantiation of the class from other classes. Private static variable of the same class that is the only instance of the class. Public static method that returns the instance of the class. This is the global access point for outer world to get the instance of the singleton class. In further sections, we will learn different approaches of singleton pattern implementation and design concerns with the implementation. A. Eager initialization. In eager initialization, the instance of singleton class is created at the time of class loading. This is the easiest method to create a singleton class, but it has a drawback that instance is created even though client application might not be using it. See an example. If your singleton class is not using a lot of resources, this is the approach to use. But in most of the scenarios, singleton classes are created for resources such as file system, database connections, etc. We should avoid the instantiation until unless client calls the getInstance method. Also, this method doesn't provide any options for exception handling. B. Static block initialization. Static block initialization implementation is similar to eager initialization, except that instance of class is created in the static block that provides option for exception handling. See an example. Both eager initialization and static block initialization creates the instance even before it's being used, and that is not the best practice to use. So in further sections, we will learn how to create a singleton class that supports lazy initialization. C. Lazy initialization. Lazy initialization method to implement singleton pattern creates the instance in the global access method. Here is the sample code for creating singleton class with this approach. See an example. The above implementation works fine in case of the single-threaded environment, but when it comes to multi-threaded systems, it can cause issues if multiple threads are inside the if condition at the same time. It will destroy the singleton pattern and both threads will get the different instances of the singleton class. In next section, we will see different ways to create a ThreadSafe singleton class. D. ThreadSafe singleton. The easier way to create a ThreadSafe singleton class is to make the global access method synchronized, so that only one thread can execute this method at a time. General implementation of this approach is like the below class. See an example. Above implementation works fine and provides thread safety, but it reduces the performance because of the cost associated with the synchronized method, although we need it only for the first few threads who might create the separate instances. Read Java synchronization. To avoid this extra overhead every time, double-checked locking principle is used. In this approach, the synchronized block is used inside the if condition with an additional check to ensure that only one instance of a singleton class is created. The following code snippet provides the double-checked locking implementation. See an example. E. Pugh singleton implementation. Prior to Java 5, Java memory model had a lot of issues, and the above approach is used to fail in certain scenarios where too many threads try to get the instance of the singleton class simultaneously. So Pugh came up with a different approach to create the singleton class using an inner static helper class. The Pugh singleton implementation goes like this. See an example. Notice the private inner static class that contains the instance of the singleton class. When the singleton class is loaded, singleton helper class is not loaded into memory, and only when someone calls the getInstance method, this class gets loaded and creates the singleton class instance. This is the most widely used approach for singleton class as it doesn't require synchronization. I am using this approach in many of my projects, and it's easy to understand and implement also. F. Using reflection to destroy singleton pattern. Reflection can be used to destroy all the above singleton implementation approaches. Let's see this with an example class. See an example. When you run the above test class, you will notice that hash code of both the instances is not same. That destroys the singleton pattern. Reflection is very powerful and used in a lot of frameworks like Spring and Hibernate. Do check out Java reflection tutorial. G. Enum singleton. To overcome this situation with reflection, Joshua Block suggests the use of enum to implement singleton design pattern, as Java ensures that any enum value is instantiated only once in a Java program. Since Java enum values are globally accessible, so is the singleton. The drawback is that the enum type is somewhat inflexible. For example, it does not allow lazy initialization. See an example. H. Serialization and singleton. Sometimes in distributed systems, we need to implement serializable interface in singleton class so that we can store its state in the file system and retrieve it at a later point of time. Here is a small singleton class that implements serializable interface also. See an example. The problem with serialized singleton class is that whenever we deserialize it, it will create a new instance of the class. Let's see it with a simple program. See an example. So it destroys the singleton pattern. To overcome this scenario, all we need to do is provide the implementation of readResolve method. See an example. After this, you will notice that hash code of both instances is the same in the test program. Thanks for watching. Please subscribe our channel. We will come soon with many more interview questions. Please like video and leave your comment.